Good morning, everyone. I hope you're doing good. Welcome to day 2 of AI DevCon. I hope you're all excited for the day. Yes? Awesome, great. Thank you so much for that introduction. This is still a small introduction slide. If you want to catch up, I started my journey with IBM as a Java technology engineer and then soon turned my passion towards DevRel and community building. And that's what I've been doing for over a decade now. I'll skip this and then move on to the actual part. I want to first understand how many of you have heard of Neo4j or worked with Neo4j? Wow, amazing. That's a lovely audience. So thank you so much for working with Neo4j and knowing Neo4j. Today I'm going to talk about how you can make your LLMs to be factual ninjas using GraphRAG. We know LLMs hallucinate, but then how can you make it better and more efficient is what we're going to cover today. But for those of you who have not heard of Neo4j or not worked with Neo4j in the past, I'll just do a quick refresher. Just bear with me for the next 2 or 3 minutes and just going to do a quick refresher of what graphs are, what Neo4j is. So when you talk about graphs, well, definitely this might come to you as a immediate thought process. This is fine. These are pie charts or your bar graphs, diagrams and stuff. But in the graph database industry, what is relevant when you talk about graphs is this, the graph theory. So you might have studied about this graph theory in your undergrad days or in your working professional days as well. So all these circles, these lines connecting with each other, that's what the foundation of graphs is. Little confused? Well, let me take you through an example. A very classic example, which I love to quote every time, is the Panama Papers. The Panama Papers was launched by ICIJ, folks at ICIJ, International Consortium of Investigative Journalists. Now, what these journalists were trying to do is trying to uncover this shady system of cash flow, money movement across various countries, people, politicians, celebrities, and everyone. So what they got hold of was a 2.6 TB of a hard drive with 11.5 million documents, and these were all not just bank statements, that they were emails, they were scanned documents, they were texts, they were images, they were a bunch of other things. So how do you make sense out of this entire hard drive? This is so many documents to process, to go through. So eventually what they went ahead with, they started taking one document at a time and they started created a graph structure out of it. So for example, in one of the documents, they found a reference of a person, and then there's a name of the person. Now, and maybe in another document, they found that, okay, there's an account, and that account is for that particular person, and that account is with a bank. Now, this particular person lives at a particular address, might be referenced in the same document or in another document, and so on and so forth. At the same address, they found maybe a reference of another person, person B, and then this person B is an officer of a company. This company has a bank in Bahamas, and there are transactions that are happening across the two bank accounts, essentially. Now, if you look at this, looks very simple, but it's a very tiny piece of the bigger graph. If you look at it, so this were the 11.5 million documents eventually taking a shape of a larger graph out there. Now, what are the graph components? The graph theory that I talked about. So it starts with nodes. These are entities which represents are things in a graph. Now, relationships represent associations or interactions between nodes, and then properties represents your attributes of your nodes and relationships using including your vectors as well. Okay. How do you do a mapping from a relational to graph? If you're still living in a relational world, this is how you can map your relational data, your RDBMS data to a graph data. Your rows maps to your nodes, your joins maps to your relationships, your table names maps to your labels, and then your columns maps to your properties. I don't want to spend too much of time, but this is a holistic approach of what Neo4j is all about. It's not just a graph database. Well, yes, we are a native graph database. We created this graph database category. We lead in this graph database category. But on top of it, we have data science and analytics. We have a lot of development tools and frameworks. Most of them are still open source. We have support for more than 13 languages, programming languages. They're the drivers for more languages which are maintained by community as well. And it runs anywhere. So if you have worked with Neo4j maybe 6-7 years ago, you might feel that Neo4j is still on-prem. No, we have an on-cloud version as well, which is fully managed service, and there is also cloud managed services as well. Okay. Uh, and these are some popular graph use cases: real-time recommendations, fraud detection, some very classic niche use cases about graphs, where graphs are super useful, super great. But we always say at Neo4j, graphs are literally everywhere. And trust me when I say this, I'm not saying this as a sales or marketing pitch, but yes, graphs are literally everywhere. You go out there, you interact with things, you see a graph, but you don't realize that it's eventually a graph. Okay, I don't want to bore you with what Neo4j is, but want to just quickly dump into the RAGs with Neo4j. How do you do retrieval-augmented generation? How many of you have heard of RAG, have worked with RAGs? Everyone? Anyone who has not worked with RAGs, don't know what RAG is all about? Couple of you. Okay, fair enough. So we know LLMs mix things up. They hallucinate, right? Even today they hallucinate, for that fact. So no matter how much advanced a LLM could be, they would still hallucinate on certain aspects. They will hallucinate maybe if you're asking something which is domain specific question, they'll still hallucinate, right? Or maybe they ask something about a future occurrence, future incident that might happen in future, so they'll still hallucinate on that. They might give you some resources to say that, okay, you can verify from this later on, or they can give you some coherent response, but they won't give you a confident answer even till date. And even till date, you have to make sure that if your responses are accurate, you have to put in some additional information, if specifically for the domain-specific questions you want to ask. So RAG became an industry standard, a grounding method to make sure your LLMs do not hallucinate. So what happened was, so when ChatGPT or GPT or all Gemini of the world launched, the process was very simple. You have your questions, you have your retriever, there's an LLM, you get an answer. Simple enough. But with RAG, you can now append additional information. You can add an additional data source and say that use this data source as a reference, pass it back to the LLM with a prompt, and say, now you give me the better answer. So that's how your answers became more accurate. And I'm sure you might have heard of vector RAG as well in the context of RAGs. So not going to the depth of it, but vector RAGs, simply you have a lot of unstructured data. I mean, structured data is simple to use, simple to work with, simple to process, good stuff. But unstructured data is something which is very difficult to work with. So came in vector RAGs as a concept and made our life much more simpler and easier. Okay, now you have, let's say, for instance, bunch of PDFs, thousands of those PDFs. Now, I mean, of course, the context length window is getting better, but then putting those 1,000 PDFs every time is, again, so much of task. So what vector RAG will do, it will take your PDFs, divide it into small chunks, store those vectors into the vector database. Now when an end user is asking a question, it does the same thing which I talked about earlier. It tries to retrieve the nearest vector. Does a similarity search, basically. Something from the query that you're putting in, what exists in the database, how similar it is, it starts retrieving the results. Now, vector RAG was amazing, and it's still amazing. I don't disregard vector RAG at all. But there are reasons why I would say that vector RAG alone would fail. The vectors alone would fail. Your vector search alone would fail. So for example, if I am having a database of, let's say, 1,000 contracts with multiple organizations that I have signed, worked with, and there could be a contract where I can have a couple of organizations coming together and then working on. So imagine I have a database of these 1,000 contracts and I want to make a chatbot. I want to search across these 1,000 contracts. And I'm asking, what are our contracts with Acme Corporation? Now, Acme Corporation could be referenced in maybe 100 documents. And in the 100 documents, maybe there are 10 documents in which Acme Corporation has been heavily referenced. So what will happen when I'm trying to fetch answers for what are our contracts with Acme Corporation? It will find answers from those 10 documents, but the actual contract that I'm looking for over here is the ones that are signed with Acme Corporation. That may be only one. Or if I have a multi-hop question, I want to go into the depth of it. That's where vector search alone will fail. So what happens? So what do we do if vector search alone fails? So we take GraphRAG into action. Now GraphRAG, as I said, we are not disregarding vectors over here, but we are appending it with knowledge graphs. So when a user asks a question and there is a GenAI application that's running in the backend, it does a graph retrieval and also does a vector search. And based on the two together, it extracts the documents and the context and passes it back to the LLM, which LLM further generates a complete response and give it back to the user. So over here, what are these knowledge graphs? So for RAGs, as I said, unstructured data is something which is super difficult. So what happens with your unstructured data, your text, your images, etc., you convert them into vectors, right? That's what the vector RAG is all about. But what is crazy and what is like mind-boggling is that you can also extract entities out of these vectors. So you have a textual document divided into chunks, and then from those chunks you can also extract these entities. Now these extracted entities can help you identify the hidden relationships, the connections which even you were not aware of, right? And then of course structured data is also simply good to use, and then your semi-structured data is also simply good to use. Now all the three together, your unstructured data, your structured data and semi-structured data, together all three can be easily put together in a knowledge graph, which we call it as a superset data structure for RAG. Now, what is knowledge graph? Knowledge graph is just like a domain specific representation of my data in a graph. So think of it as a larger graph with multiple subgraphs combining together. So it could be a graph for a structured data, it could be a graph for unstructured data, and both structured data and unstructured data graph could be connected together and eventually forming a bigger knowledge graph. So as I said, your data is always connected, but we never realize that data is connected. We always feel that our data is siloed. So you might have an employee's graph as a separate graph. You can have a supplier's graph as a separate graph, a product graph as a separate one, a customer's as a separate one, a transactions as a separate. I mean, think, even if you still want to think in a relational world, you can have an employee's table, you can have a supplier's table, you can have a product table, but think from a top-down approach. You see that you're interacting, a customer is interacting with a product also, a customer is interacting with an employee also for a service, for a feedback or anything. There's a network security also, there's processes also, there's transaction that's happening. So all of this is rather interconnected with each other, and that's what we call it as 7 graphs in an enterprise. But I mean, of course, there are more than 7 graphs, or there could be more than 7 graphs in an enterprise. But yeah, coming back to our knowledge, but this is what looks like a knowledge graph as well. Now, these knowledge graphs can be divided or kind of categorized, I won't say divided, but kind of categorized into 2 types. And this is more like an internal terminology which we feel would be more relevant for developers as well to understand what knowledge graphs are and how it's kind of structured. So there could be a lexical or a document graph, which is like a graph documentation, graph representation of your documents, your paragraphs, your chunks. Now, another thing which I realized with vector RAG was your vectors were just lying in your as an embedding. There was no connection between your chunks also. There was no connection between your vectors. So that's what happens in your lexical or document graph. So your chunks are also connected with each other and also to the main source, main document source. And then, as I said, there is a process where you can extract entities and relationships out of your chunks, and then you create a domain or an entity graph. So it's nothing but it's a graphical representation of a real or a digital world that you're trying to model. Now, these 2 graphs do not exist in silos. They are rather connected with each other. So your chunk could have a mention of maybe 2 topics, 2 entities, one chunk, and then there's another chunk which also mention of the third entity. Now these 3 entities are rather connected with each other, which you don't realize. So together with Neo4j and GraphRAG, you can achieve higher accuracy and relevance in with real-time updates. We have seen this, by the way. We have seen 3x accuracy happening. The performance is faster, the development is accelerated as well. And the foremost part, which is very critical to enterprise these days, is explainability and governance. You can go to the node level, you can control which one has the access. You can put some access level policies over there. You can find out, when I say explainability, the black box nature of vector RAG fails to help you give an information in terms of how the answer came in, what was the metrics about it. So your GraphRAG can give you an answer and tell you, okay, these are the chunks that were used, these are the sources that were used, these were the entities that were fetched in, and then you can evaluate your answer, and then you can maybe upvote it or downvote it as well. I mean, you can build an agentic framework later on as well. So ultimately, you can build your next Gen AI breakthrough with deep context and explainability using a GraphRAG approach. How you do about it? Well, the first thing foremost is to build a knowledge graph. Now, this knowledge graph, as I said, could be a combination of your unstructured and structured data and semi-structured, or it could be just purely unstructured data. It depends on totally upon your use case. It can totally be a completely unstructured data knowledge graph, or it could be a structured data which you might have already have it existing in your database, and then you can append it with the unstructured data. And then there could be a concept where it extracts the nodes and tries to find if the nodes that already exist in your unstructured, in your structured data or not. And then you can converse on top of that data. You can build. So I'm going to cover up in a while, but you can converse. You can build some agentic frameworks, agentic chatbots as well, and then converse on it. There are a lot of LLM framework integrations that we have made, and that helps your development process much easier. If you want to know more about the GraphRAG, what is it, how it's helping enterprises these days, this is something which I'll definitely recommend for you to go and read. This is a GraphRAG manifesto that's written by our CTO, Philip Ratley. An amazing piece of article in terms of how you can achieve GraphRAG and how it is helping enterprises these days. So I'll definitely recommend you to go back and read this GraphRAG manifesto as well. From there, I'll jump on. Oops, I think. Okay. So when we talk about building a knowledge graph or creating a knowledge graph, there has always been a question. It's super tough, especially for your unstructured data. Well, yes, I do agree on that. It is not an easy process to build a knowledge graph out of your unstructured data. So what we created is this nice LLM graph builder tool. It's a low-code environment, rather it's a no-code environment, a fully open source tool. You don't even have to provision your API keys. You can run it on your local LLMs as well. You want to run it with Olama, that's also doable. You have your own API keys you can put in as well. But when you run it in the production environment, you do not need any API keys, by the way, for that matter. So what's the process? Just a simple three-step process. You connect to Neo4j instance, you upload your files, your PDFs, your YouTube. It even supports YouTube transcripts. It even supports your YouTube videos, your Google Cloud storage as well, your AWS storage as well, Wikipedia pages, web pages. It scrapes your web pages and starts creating a graph out of it. And just click on generate graph. You select your LLM, which LLM you want to use, and then it generates graph. And what it does, as I said, it creates two sets of graph. It creates a document or a lexical graph, and also creates a domain or an entity graph. And then you can visualize it. You can explore the graph directly within the tool, or you can go back to your Neo4j or a console, and then you can visualize it from there. If you want to experience the power of GraphRAG within the tool itself, we have also provided a chat interface, which has multiple chat modes. So we have given an option where you want to test it out, maybe how the response looks like if I just want to go with a vector search, how the response looks like if I want to go with a vector plus full text search, how it works with vector plus full text plus graph search, or how it looks like with a local community detection. So we have given all those chat modes to you. You can select, you can filter out, you can select multiple of them, and then it starts giving you a response based on the ones that you selected. So as I said, this is hosted on this particular URL. There's a nice documentation available. You can read more about it. If we have time, I can also show you a quick demo on how the tool looks like and how it works. But I would strongly recommend you can definitely check this out. It's an amazing tool to work with. Then, as I said, while it's on the production, you cannot add in any API keys or run it on local LLMs, but you can run it as a local instance or host it on your own instances as a Docker image, or run our front end and back end separately and then host it separately. So you can go to this GitHub and then you can find more about it. I think we have time. I can show you a quick look of how the tool looks like. So this is the tool. As I said, simple drag and drop of your text documents and structured documents. Your web sources also has YouTube, Wikipedia pages, your web pages as well. There's Amazon S3, GCS as well. Now, in the production environment, we give couple of LLMs for free, but of course there are some limitations in the backend. So if eventually if you come back and tell me that, hey, the tool doesn't work because I'm trying to process a 1,000-page document in a single go, well, yes, we have put in some guardrails at the backend so that we don't overshoot our limit as well. So maybe the best way is to divide those 1,000-page document to a smaller size document as well. And that's what I've done. So if you notice over here, there was a document, the name was 12.pdf, so I divided into multiple documents so that I can process it faster. And eventually you can see, clicking it over here, for each document, it creates the chunks. You can visualize it directly from here. Let's see if the net is good. It takes a little while based on the internet connectivity. Using my phone hotspot. Let me just see if I can. Okay, let's try and explore any one of the PDFs now. This is my main document, and then if I just deselect the entities, these are the chunks that were created out of this document for me, and then all the chunks are connected. There's a relationship between the chunks. I can go into each chunk and then find more. I can just deselect and find only the entities that it has extracted. There's some, for sure, there might be some orphan nodes as well which do not have any relationships. So it's up to you. You can remove those orphan nodes as well. You can go back to your console, and if you want to filter out and see if you want to remove anything, you can do that as well. So it's not schema rigid. It's very schema flexible, so you can change your schema anytime later on as well. Now, I want to also touch base on a couple of things within this tool which makes your life much more easier is this graph enhancement tab. So for few regular use cases like movies, Stack Overflow, I mean, these are very generic use cases. We have already defined a schema for you. So if I select, let's say, a movies database, it automatically populates a schema of nodes and relationship types. Now I can filter this, I can remove some of the nodes, I can remove relationships. Now what happens is that if I'm giving a random text, it starts using this schema as a reference point and starts creating new nodes and relationship based on the schema. If I don't do that, if I have my own use case, I don't want to do that, I can define my own schema as well. So if my database already has a schema, it goes back and checks the existing nodes that you have, existing relationships you have. You can select which one you want, which one you don't want, as a reference point for the tool to generate new nodes and relationships. Or alternatively, you can keep it blank and it does the job on its own. Another option is you're not sure, okay, what's the schema looks like. So what you do is you can get schema from text, you can paste a random, maybe a half a page or 1 page of sorts, and then you can say analyze text to extract graph schema. It analyzes some nodes and relationships for you, and then you can further filter it out from there. So that's one amazing part. Another is these additional instructions. You can put some chunking size. So we have defined the chunk sizes, chunk overlaps at the backend as a generic one, but if you want to configure it further, you can do it within the tool. You can put some token count per chunk overlaps, chunks to combine, etc. As I said, there would be some orphan nodes as well that we saw earlier. If you feel we do not want these orphan nodes, there's no relevance of these orphan nodes, you can just directly click from here, delete all the orphan nodes directly. There's a deduplication of nodes. Sometimes what happens is, for instance, Apple and Apple incorporation may be same, right? Or let's say Bangalore or Bangalore or BLR, everything is kind of needs to be same, but it creates multiple nodes. So you can use this deduplication of nodes. It tries to identify whether these nodes are similar, and you can club these nodes back again. And then there is post-processing jobs as well that you can explore. Now, coming to the chart which I mentioned, so you have all these chart options. You can go with only vector search, you can go with full text search, you can go with graph plus vector plus full text, you can go with an entity search as well. But if you go to the dev environment on GitHub, let me just show you the dev environment. So you have more chat options that gets unlocked. and then you can also use with bunch of other LLMs. For now, we just support few LLMs on prod without the API key, and then these LLMs, rest of these LLMs are all supported on your dev version, but you can I mean, you can come up with your own integrations as well. You would have to do the task of coming up with your own integrations for other LLMs. But if there is an LLM, any LLM which is deployed on Ollama, I think everything works fine then. In that case. So here I can chat directly. I can say, so this is my personal chatbot which I built on Mahabharata. I can say, I can ask it and say who killed Karn and why. Hopefully the demo god is not mad at me and gives me a right answer. Any Mahabharata experts in the house by any chance? No? Okay. So Karn was killed by Arjun during Kurukshetra. That's right. The context reveals that Yudhishthira, the son of Dharma, provoked Arjun to slay Karn by speaking harsh words. As I said on the explainability part, you can go back if you feel the answer is not wrong. You can go back, have a feedback loop later on. But you can see, okay, these were the sources that were used. What are the chunks? What was the similarity score? What was a graph within that particular chunk that was referred to? You can go back and see all of that information as well. What were the top entities used within this? That also you can go back and refer. And then there is the evaluation framework metrics as well. You can see, so we have implemented this Ragas framework, so you can see that how we are evaluating a particular response. Cool. By the way, this I ran with GPT-4o. I can change the LLM as well. So I can use one LLM to extract and another LLM to retrieve my answers. So I can do that combination as well and see how the responses looks like. I can change my modes as well. Right now I'm running in a graph plus vector plus full text mode. I feel that that's the most ideal mode and the one that gives the kind of the most accurate responses so far. In my personal experience, that's what I've seen. It does a vector, it does a full text as well, and it also does the graph retrieval. So everything is there for you. So let me go back to my presentation. Okay. So, well, yes, this is like a no-code framework. But if you want more control, you want to build a system where you have further control. We have also come up with this GraphRAG Python package. This was released, if I'm not wrong, last year. This was earlier named as Neo4j-GenAI, which is now renamed it as Neo4j-GraphRAG. So this package is super amazing. It gives you a bunch of retrievers, but it also helps you build your own knowledge graph. So what we did over here in this no-code environment, you can also do it the same thing in this GraphRAG Python package as well. An amazing package, to be honest. I'll show you a demo as well, the same Amara demo if I have time. So you can build a knowledge graph, you can implement your knowledge graph retrievers, and then you can create your GraphRAG pipeline out of it. So when I talk about retrievers, we have built in a vector retriever, we have a vector cipher retriever, there's a hybrid retriever which does a vector plus full text, and then there is a hybrid cipher retriever as well, which does vector plus full text plus a cipher query. And then you also have something called as text to cipher. So a lot of developers reach out to us, hey, writing a cipher code is kind of difficult. I mean, I don't say it's a difficult thing, it's super easy. But how do you make sure that an LLM can also help me do a text to cipher? So we created a text to cipher LLM, a fine-tuned LLM on top of a foundational model. And then foundational model, that fine-tuned LLM is also is getting integrated with text to cipher retriever as well. So you can just put in a natural language and it converts it to a cipher query for you. Okay, let's see if I can run that particular query. I mean, don't mind, it's kind of in a rudimentary way right now. So it uses OpenAI for this one, and I can just change it to hypercipher and can say, why did Pandavas go to forest for 12 years? Let's see. If it doesn't work, then we can always blame it on demos. But yes, it worked. So Pandavas went to forest for 12 years as part of their conditions for losing a game of dice, which is correct. According to the term of game, the losers had to go into exile for 12 years, followed by a 13th year incognito, which many don't know, during which they had to remain undiscovered. If they were discovered during the 13th year, they would have to repeat the cycle of exile. So, okay, I got a response. I'm happy with it, and then I can build another fine-tuned version of this chatbot as well. All right, so moving on from here, I'm almost towards the end. So ultimately, you can integrate with the entire GenAI ecosystem that you see out there. We have integrations across all the LLM frameworks. You have LangChain, Llama Index. I just named 2 of them, but you also have integrations with Haystack and Spring AI. Super compatible with all the generative AI LLM models and embedding models as well, be it from OpenAI or from GCP or Azure or AWS. Integrates well with everything. You can build your Streamlit applications, you build Gradio applications, you can build your custom applications as well. There are drivers as well for all the languages. Deploy it on Cloud Run, deploy it on Vercel, deploy anywhere you want to do grounding with knowledge graphs using Neo4j. And I'll leave you with this one before I jump on to the last section, which is the resources. So this is like a GenAI reference architecture, which I love to put across to show you how the data ingestion and data retrieval process looks like when you use Neo4j. So you have multiple data sources, unstructured, structured, semi-structured. You use the Graph Builder tool or use the GraphRAG Python package, insert everything into Neo4j, create a knowledge graph out of it. Then in the retriever, you create these chat applications, and then these are a bunch of end user use cases. Again, not just restricted to them. You can come up with your own use cases. But yeah, just something for the reference for now. All right, so just a couple of resources. Want to learn more about what we are doing in the GenAI world? The documentation link that you see, neo4j.com/labs /GenAI-ecosystem. That's the place to go. It has all the integrations, the documentation, everything over there. More fancy stuff is there on neo4j.com/GenAI that you can also check out. You want a free instance of AuraDB, our fully managed database as a service? Just go to neo4j.com/cloud/aura free, or just simply type in console.neo4j.io and you'll land up to AuraDB. Free, and then you can also explore Sandbox. There are a bunch of options. But what's amazing is this Graph Academy platform. There are tons of courses on not just Neo4j and Neo4j fundamentals, intermediate, advanced, but there are so many courses on GenAI that we have launched, and we'll be launching more courses in some time. So you can take up certifications. There are 2 certifications for free that's available. Take up these self-paced hands-on courses and get yourself updated on what's happening in the world of Neo4j and graph databases and GenAI. With this, I'll end my talk. Thank you so much, and happy to take up any questions if you have. Yes?
What is the size that you can actually put into RAG? How much data?
No limit. I mean, the chatbot which I built, that was probably the PDFs altogether would be close to around a GB. Not too long. I mean, but from that 1 GB, it also depends on your use case. By the way, how are you comfortable in extracting more in nodes and relationships, or you just want to limit yourself to a structured data? Structured data, it's a very smaller footprint. If it's unstructured data, then you might have to figure out a way to process them. But there's no limit. I mean, Neo4j can scale to any level, for that matter. From just less than 1 GB of my data set, I was able to create probably around 50,000 plus nodes and 500,000 plus relationships. So imagine if you have a larger data set, you will have a bigger graph altogether. I mean, if that is not of a concern, then there's no limit.
Does that mean that you have no limit there?
Uh, there might be a need to fine tune, depending again on the use case. But for now, what I have seen with the tool and with the package, both in a combination, uh, I haven't got a need to do a fine tuning. In fact, the chatbot which I showed you, this was extracted with probably version 1 or version 2 of my Graph Builder tool. So the Graph Builder tool is advanced now. I mean, I don't remember the versioning, but it's much more advanced. There are almost like tens or 20s of releases that have gone so far. But it has done a fairly good jobs even back then. What's the? There is no latency as such. It depends on your Aura instance. I mean, Neo4j instance, what's the capabilities of Neo4j instance? That depends. So, for example, when I started, I was able to generate a graph, but then eventually, at certain stage, the processing stopped for the next PDS because I was able to hit my limit for Aura. So then I changed my Aura free to an Aura Pro instance where I had to upgrade it to more nodes, more relationships. So it worked fine. The processing was done, but when I was extracting, sometimes it had to go for multiple hops, right? Maybe 10 or 20 or 30, for instance. Now, in those scenarios, if you are running on a slower Aura instance with lower capabilities, then your queries response would be slower. If you are running on a maybe let's say a 64 GB, 32 GB instance, then your queries would be faster retrieved, right? It purely matters on the Neo4j Aura instance that you're providing, or if you want, you can run it on a desktop version, have a dedicated 128 GB rig and run it over there, depending on use case. If your limit is good enough for 128 GB, then it's good enough as well. So there's no latency as such until and unless there is you hit the bottleneck of your Aura of a Neo4j instance, not just Aura. You.
Hey, first of all, thank you for this exhilarating session. Really appreciate the insights. I had a few questions about a way how I can embed this in our RAG implementation. So I saw that you were referencing about text chunking service. So can
Referencing about?
a text chunking service?
Right.
Right. So can we call external services, like I've got a microservice that I use to chunk my text.
You can.
So
You
I
can.
can call external
You can.
services to text.
Yeah.
Okay, awesome. And
I mean, the tool would have limitations in terms of how much you can customize. But if you want, you can go with your native integrations with LangChain, Llama Index, Haystack, and Spring A and call anything. And combine it with GraphRAG Python package as well.
awesome. And I saw you within the RAG Builder tool. You had mentions of several models that you integrate with, right? So, is your release cycle coherent with the models that come out every week or month?
So, as I said, we do support these LLMs for now. So we keep updating these LLMs as soon as they get released, but we don't provision them in the production environment. We provision them only in the dev environment. So the integrations would be there, the support would be there, but they won't be enabled for the production environment. I mean, for this particular URL that you see over here, this LLM graph builder.neo4j labs, it won't be enabled over there, but it would be supported. So you can run it as a local instance. I couldn't show it today, but I have a local instance as well. I tested it with Llama 3, the latest version, and then it works fine. I mean, everything works fine. So we keep our tool updated with latest LLMs as soon as they get released, and we try to put in a support for them. Initial part is just to build an integration. So for example, if DeepSeek launched today, imagine. So we just have to build a DeepSeek integration. But what happens in the backend with DeepSeek, they come up with a new LLM version. The LLM model name has to change. That's it. So we don't spend too much time. We don't have to spend too much time in terms of like testing it with new LLMs every time.
Right, I see. Another question that I have was, can the knowledge graph that came out of the whole RAG builder, can it be deployed to any PaaS services like Azure AI Search Service?
You can.
And I can deploy those. So under the hood, is it like a single vector?
So no. So when you say you want to deploy a knowledge graph on Azure AI, or you
Yeah,
want to connect your Azure AI to our Neo4j instance? I mean,
I wanted to deploy the knowledge graph that came out of the RAG builder.
no. So the knowledge graph would still sit in Neo4j, but you can connect with your Azure AI services and integrate it with the knowledge graph that's sitting in Neo4j. So you cannot take out the knowledge graph from Neo4j directly. You getting my point?
Right, because I saw in your integration, the actual vectors are being stored in an S3 instance, right?
Yes.
So in our particular use case, we use the Azure AI Search Service.
So you can use Azure AI services to interact with the knowledge graph. So we have a lot of native integrations with Azure AI, where it can directly talk with our Neo4j instance and connect with your knowledge graph. But you cannot take out the knowledge graph and then deploy it as a separate offering onto your Azure AI instance.
And is your retrieval APIs? I mean, can I use any other retrieval API to interact with the knowledge graph?
You can. You don't want to use GraphRAG Python package, totally fine. You do not want to use the function that we showed you, that's also fine. In fact, the version 2 of the chatbot which I just showed you, I also have a prod version which is a little buggy, but the version 2 of the chatbot that I built was not using any of these retrievers, was not using any of the chat options that I showed in the tool, but it was purely a prompt engineering, a prompt template that I passed on to, let's say, Vertex AI, to OpenAI, and then I created the retrievers from there. So that is also doable.
I see.
Yeah.
Thank you.
Why I would recommend these retrievers, and the reason why I am also switching to these retrievers, one, it reduces the development time, and the retrievers are much more advanced as compared to writing your own code. So you eventually, if you write your own code, you would have to do a lot of prompt engineering and prompt template additions, right? Your retrievers are much more efficient. These retrievers have done a great, the team behind them have done a great job in building these retrievers so that your life is easier when you're trying to build something like this.
I see. Thank you again for the session.
Thank you. Cool. I think there's one more question. We'll take that. Okay.
Hey Sid, that was a beautiful demo you have showed. So I've been working on a graph-based system for a long time. Graph systems are more focused on structure, right? If I give more structured chunks inside the system, I would get a more accurate context from the system. So previously I've been using LLMs to create more structure output and then push it inside the RAG system. Is there any optimized way to do this? Because tokens price are pretty high, right? If I generate more number of structured tokens from LLMs, it would be more costlier. But
the tool and this package doesn't need that kind of structure. You do not have to define a schema for that. So it does a job at the backend where it extracts on its own. So no schema definition has to be passed on. So no structure has to be defined. It does it on its own. You can control, why we have put in these schema definitions is just to ensure that you can have some guardrails as well. Because a lot of people come back to us and say that, hey, you do not have any guardrails. We cannot control what's happening. So for those scenarios, and we want to cater to all the edge scenarios as well, that's why we created these schema definitions within these tools and within our package. But it's optional. You can skip that and just go with the regular unstructured data as well.
Got it. Perfect. Yeah,
Awesome.
Thank you.
Thank you so much.